Science Mom here with Math Dad, and today I have a challenge for Math Dad.
Uh-oh.
So I'm going to challenge you to take an entire roll of tinfoil, crumple it into a ball, and then compact it down enough that it becomes completely shiny and smooth. The aluminum ball challenge.
I've seen this.
So a few quick things I want to point out to you. First is that when you get it into a ball shape, you really don't want to pound hard and deform the ball. You want to keep it in a ball shape. Otherwise, you're headed for disaster and cracks and a big mess. And then second, I'm going to let you choose. One of us is going to sand the ball, and one of us is not going to sand at all. So we're going to have hammer versus sanding. Which one do you want? I'll let you pick.
Sanding. I pick sanding.
All right. On your mark, get set, go. In this video, we'll also share some cool facts about aluminum, when it was first discovered, how it bonds, and why it's one of our most commonly used metals today. Alright, so we have rolled the entire thing into a ball. Let's hold them up for comparison. Pretty similar. I think yours is just a little more compact than mine.
It is superior.
And now we'll get started hammering. Before we get started hammering though, I want us to do earplugs because the hammer's going to be loud. And I don't have earplugs, so we're going to use Kleenex instead.
Okay.
It's good for you. Your ears will, when we're like 80 years old and you can still hear me, you'll thank me.
Yes, dear.
Alright, and just start the timer. Now, we started out with just tapping the balls and trying to shape them with our hands to be more compact, and then we took out the hammers and hammered and hammered and hammered. So we've been pounding for about 5 minutes now. I did have some mason lids if you want to put this underneath so we don't bang up our wooden surface so much. That'll provide just a little bit of a cushion. And I have a question for you about aluminum. When do you think aluminum was first discovered? So first, quick little background. Iron was discovered thousands of years ago. Yeah, so I mean, you had like the Bronze Age, like 9000 BC, we discovered, used copper. And then, depending on where you are in the world, between like 5 and 3000 BC, iron, mercury, lead, silver, gold, all of these metals were discovered thousands of years ago. When do you think aluminum was discovered?
Let's be more recent. I think about 1642.
1825.
Dang.
Yeah. And it turns out to purify aluminum, you have to have a huge amount of electricity. We actually smelt it by getting it molten and then running an electrical current through it. Kind of like a huge, dangerous battery. Yeah, that's why they didn't have aluminum back in prehistoric or pre-electric times.
Cool.
So it's been about 13 minutes. And I feel like here is where a lot of people would say, oh, I've made it into a ball and now I can sand it. That would be a big mistake in my opinion. There are a lot of little grooves still, and if we pound for like another half hour, we will wear down a lot of those grooves so that then you could sand it, but if you sand it now, you're just going to flake off a whole bunch of aluminum. It's not dense enough yet. Still has a ways to go.
It's not shiny like I've seen.
Not yet, but it'll get there. And it can get there even with just using a hammer. No sanding or polish required.
If you say so.
There are a couple neat things happening as we pound. First, the balls get warm to the touch. Energy is always conserved, so some of the kinetic energy from the force of the hammer hitting the aluminum is converted into heat. And second, let's take a quick look at the element aluminum, which is number 13 on the periodic table. Like most metals, it's not particularly attached to the electrons in its outer shell.
If you want them, you can take them.
When it bonds with other elements, it loses those electrons. If you get a bunch of aluminum atoms together and give them back their electrons, then something really cool happens. The electrons aren't being held tightly by any individual atom, so they form an electron cloud that is shared by all of the atoms. This is why aluminum and other metals conduct electricity so well. And it also helps explain why aluminum is malleable or ductile. The individual atoms aren't attached to each other through covalent bonds or ionic bonds. They share a metallic bond, which is kind of like existing in an electron soup. And this means that if you pound and push on a ball of aluminum foil for long enough and hard enough, it can be formed into a solid mass. It's been 26 minutes now. I'm starting to get hot. It's a lot of work.
Indeed it is.
Hammering.
I wish I was more coordinated with my left hand.
Yeah, it is nice to be able to switch back and forth. And aren't you glad you have earplugs in?
What?
When you're an old man, you'll thank me.
Eh?
It's been about 45 minutes. Math Dad just left to go sand his ball. They look pretty comparable. Not getting nice and smooth. We can see a bit of a reflection in them, except we both have where the final edge of the aluminum is. It kind of lifts up, and no matter how much you pound, it seems like that won't really blend in with the rest. So my guess is that when you start sanding, that part that's not attached will just sort of come right off. I'm going to keep pounding on mine and see if I can't get it to mesh in just a little bit finer and to go a little smoother. So that edge right there is a bit of a issue still. Oh look, if I wave, you can see me waving. And then of course you can see the bright lights up above. Let's go check on Math Dad. Anything you want to say?
Wow. My hands are gonna be numb.
It's been an hour and 2 minutes since we started pounding. Oh, my arms are getting tired. Ooh.
The shininess factor is not there. I don't know anything about polishing metal, but
What grit sandpaper are you using?
that's a 320. That's extra fine.
Is that the finest you have?
That's the finest I've got.
Notice that Math Dad is wearing a mask. Air in the lungs is good. Metallic dust in the lungs is bad. Very bad. Anytime you are sanding metal or dealing with metal powder, fines, or dust, you too should wear a mask. Alright, it's officially been an hour and 30 minutes since we started, which means the movie that our kids are watching is going to be ending, so it's time to be done. What do you think, Math Dad? Which one's more reflective?
Alright, we'll call it a draw.
Not a draw. Mine's clearly shinier. And it's smaller too. So we're going to declare Science Mom the winner in that little challenge because my ball is shinier, although I will concede that if Math Dad had had finer grain sandpaper and maybe buffing compound and more time, probably could have.
Yeah, that was the problem.
But point being, you can get this pretty shiny just with a hammer. Sort of a meditative way to create something, hammering away, exercising patience and perseverance because you have to be careful to not pound too hard initially to keep it in shape and then just gradually work it down. It takes a lot of time though, good hour and a half of pounding, which is...
That's true. This is not a casual project.
No, it takes some time and effort, but pretty cool. Gotta say though, my favorite project to do with aluminum is not making a ball, it is making a chaos bottle. Come closer and take a look at these. When you shake it, you get these beautiful swirling patterns. This one has aluminum powder and purple food coloring. And then of course we can have red, green, and blue. Isn't that amazing? These are so incredible to watch. If you're familiar with my channel, you know that I often post little foldable books and printable worksheets for my patrons on Patreon. Well, I am working on some cool handouts about the chemistry of aluminum and metallic bonding right now, and I would love to post them along with the Chaos Bottle video as a celebration for reaching 100 patrons. So if you love science and would like to support this channel and see the Chaos Bottle video sooner rather than later, check out my Patreon page. Each time someone joins us, we get closer to unlocking awesome goals like producing videos over the summer, bringing Science Warrior to the channel, and being able to continue the educational outreach I do during the school year. Just click the Become a Patron button, choose your pledge level, and sign up. Did you know that aluminum is the most recycled metal? If you're done with these after you make one, don't put it in the trash. Recycle it. I did a smaller test ball yesterday, and just with hammering, no sanding involved. And with this one, I hammered a little longer and it's smaller. It got a lot more dense. This one is not as compact. So I think if I spent like another 40 minutes pounding this one, it of course wouldn't get as small as this one, but it would get a little more dense and perhaps a little more reflective, although I'm pretty happy with both of them.